All right. Hi, everybody. My name is Maximilian Isensee. I'm one of the co-founders and CEO of Kitekraft. We set out to build flying wind turbines. As crazy as that might sound, but you actually see on the picture here, that's our prototype flying. So that's a 2.4-meter wingspan prototype. It already is a complete system, including everything that it needs to basically does what it's meant to be. Why do we do that? Why do we need that? So conventional wind power is great. We love it as well. We want to see more of it, but it actually comes with some issues. So you have high regulatory hurdles. You have logistical challenges to bring it in a lot of places, long permitting processes, public opposition, wildlife issues, so on and so forth. So there's a lot that's hampering the faster deployment of wind power than we would like to actually see it nowadays. So that's where we come in and try to build a wind turbine that is 10 times better. 10 times here is related to the material consumption that we have per terawatt hour produced. So that's the graph that you see on the right. Because in the end, what we do is we replace this very large nacelle and rotors with this very small kite in the air, and then the tower actually becomes this very small tether that we have as a system. So that's what we do. More in detail, it looks like this. So that's actually the drone that you see here. We have a biplane wing. Onto it, 8 rotors. We use these rotors to start and land the system, just like a drone. Once we're in the air, we go into a figure-8 flight pattern. So just like a lying figure-8, you would imagine. And once we do that, we can actually produce energy with these same small onboard rotors, send the energy through the tether to the ground station, and have a wind turbine. The goal is really to cut the cost for wind power in half. That's mainly done by the great material reduction that we already have, but we're making it cheaper along the whole process of the wind turbine chain, basically. So we can produce it quite decentralized. It's much easier to produce. We can ship it quite easily. We don't have these large blades, right? These can be done. Our shippings can be done with a regular truck. So not such a hassle there. Then actually setting it up, maintaining it, everything can be done from the ground, basically. So we don't need high cranes, specialized equipment, or crews to actually do that. So with that, we want to actually increase the speed that we can build wind power once we have it ready. Where are we now? So we have this fully functioning system. Here you see it actually with the ground station. It is a prototype right now, but we're going to a grid connection on our test site in the next month. That will allow us to go for really long-term flight tests, and then with that go straight towards a pilot system that we can implement ideally with the customer at the end of next year. That's the plan for now. So we have a pilot contract with a microgrid company for initial 100 kilowatt systems. We have a MOU signed with a project developer who's interested to implement first 500 kilowatt systems. And then we have a lot of LOIs for the small as well as the large scale systems. What's the plan that we have here? We do want to get as soon as possible into the megawatt range. So that's where we really want to build our technology into. But we start with early systems in the 100, 500 kilowatt range to start getting operational experience as soon as possible. That's really the goal that we have with these systems. That is necessary for our own development to inform the upscaling, inform the maintenance decisions and planning that we want to do, as well as make or create a track record for insurers, for banks that we need to actually scale it toward these systems. But then in the end, one system will be roughly equivalent or an equivalent scale than a conventional wind turbine will be right now. So the road to that, I already mentioned that briefly. So we have this prototype right now. Next will be a first pilot at the end of next year. With that, we can then prove first power curves and really show that the simulations that we have of our systems and what we predict is actually making sense. And from there on out, it's actually rolling out in 2025 a first of these 100 kilowatt system at a customer site. Ideally, this will be done in Germany as a starting point. And then 2027, we're looking towards the first system that's reaching the megawatt scale. We're a spin-off of the Technical University of Munich. That's where we also founded. Right at the beginning of the company, actually, in 2019, we went through Y Combinator, and that's the founding team. We have already raised 2.5 million for the company so far, and are now looking to raise our next round at the end of the summer. So happy to talk to everybody who would be interested in this, and thanks a lot.